So it's a very interesting topic that we have today, artificial intelligence and machine learning, model risk and regulatory oversight. And to speak on today's topic, we have with us Sanjay. So Sanjay has been doing, like, again, leading work in the field of machine learning and risk applications in various international banks. So just to give a brief background of Sanjay, Sanjay has done his MBA and an MSc in machine learning and artificial intelligence from Liverpool John Moores University. He also has a PG diploma in machine learning and artificial intelligence from IIIT Bangalore. Currently, Sanjay is working as a director for UBS in their risk modeling and analytics team, which is part of also model risk management and control in the CRO function. Sanjay is a risk management and analytics professional with more than 15 years of mainstay experience in risk models and methodology space, encompassing all areas: Basel, advanced AIRB, IFRS 9, IMM, SSE, CR exposure, XBA, FRTB, OTC derivative, valuation and pricing, and other advanced modeling topics. Previously, he has worked with various foreign banks, including Barclays, RBS, CD, Credit Suisse, mostly in the risk consulting departments and teams. He is also a very passionate educator, and I can vouch for that fact. He has been deeply associated with us at IIQF in our teaching endeavors, and he loves imparting practical model understanding and insights, and has been a professional trainer for corporate and investment banks. His areas of interest are majorly credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning. Right. So I will hand over the session to Sanjay. So first of all, thanks so much, Sanjay, thanks for joining in. No, I think you are on mute.
Yeah. Hi. Good morning, everyone.
Right. So before I hand over the session to Sanjay, a very quick laydown on how we would go forward in the session. So, I mean, as you all know, the session would be of about 1.5 hours. First 1 hour, Sanjay would be discussing on the topic for the day, and then which would be followed by Q&A. The allocated time for Q&A is half an hour, so it's total about 1.5 hours session, right? So anybody have any questions, queries now, later, during the session, after the session, please feel free to type in the chat window. We would be happy to take it up, right? So we want the session to be very interactive. We want to have as much discussion as possible. Of course, since the participation list is quite large, so we cannot unfortunately allow you to speak up, but nonetheless you have the chat window to type in, and we would be happy to discuss all your questions and queries. So with that, I will hand over the session to Sanjay. Whenever you are ready, please feel free to start.
Please go ahead. Yeah. So I hope my slides are just visible, viewable by everyone.
Yes.
Yep. Thanks for confirming, Nitish. And from my side, at the outset, a very warm welcome to all the participants who have been very excited to deep dive into this crucial topic, which is very much changing the landscape of AI/ML adoption in BFSI. And we would be, as part of this particular session, we would be covering all the crucial aspects. Yeah. So the starting focus, and where maybe the buck starts, where all this broadly overarching framework has been laid out, we will be starting there. What is the regulatory review focus? So to just baseline our thoughts, maybe under which particular guidance or maybe pivot we are working. And then we would be talking about the main core part, that how banks as on date are calibrating their model development and validation strategy. What kind of model evaluation, validation, verification focus banks are putting in there as part of the strategic framework to align with the regulatory requirements. And then we would be also be talking about that it's not just a thing about quantitative testing of the model. There are certain other aspects of the model which will enhance the AI/ML model usability and applicability to broad base different problem statement and use cases, where we would be talking about uh, an area which is called explainable AI, and we would be talking about AI and ML model explainability and or interpretability, and some of the ethical focus, right? And then we will circle back to showing you some of the specific regulatory papers, right? A brief overview of those regulatory papers which are providing specific guidance around the adoption of AI/ML models for various problem statements and use cases and applications within the bank, be it on the front office side, middle office side, or back office side, right? So let's maybe just start with our first one, right? That that is the regulatory review focus. So the thing is, a bit of the background that why regulator is so concerned about this huge tsunami of big data and the adoption of AI/ML models, extensive use of AI/ML models for all applications, risk management applications, as well as pricing applications, valuation applications within the bank, right? So the thing is that some of these models are as on date and very recently being considered as completely black box by a regulator, right? So when they had their first chance to reviewing these models or for approval, they could not understand how what is the internal mechanics of these models, how these models work, right? How these models do the estimation of the key relationship, how they find patterns or signals, how they denoise the data, right? How they what kind of, because very much withdrawn from the traditional or conventional way of doing modeling, which is a methodology driven or assumption driven modeling. This is quite unique because here we are doing data driven modeling. We are not relying on any hard binded assumptions like any regression assumptions or generalized linear model assumptions. We are not hard binded on any theory specifically. We are not even assuming that maybe our data or underlying data generating process, our data is coming from a particular distribution like Gaussian or normal distribution. So with all of this, that maybe data would not come from a specific distribution, it could come from variety of distributions. The estimation technique doesn't have an assumption under which it is working, like linearity. It doesn't assume that the relationship is linear, right? Strictly linear, right? uh, uh, the other part is that we don't generally hard enforce that much of a theory around like the market equilibriums, right? The martingales, or maybe how risk neutral pricing. We don't strictly enforce as much theoretical as framework as we do under the traditional numerical and statistical models. Now that maybe somehow it is quite obvious that when regulator would see this, and it is pure data driven way of doing modeling, where data is telling you what is my distribution, what are my distributional properties, like what is my measure of central tendency, what is my the dispersion or variance, what is my skewness, what is my kurtosis. The every time the data is changing, the model is adjusting and dynamically recalibrating itself. uh, there are no assumptions, like we are not strictly assuming that it is linear. So the machine learning models are naturally good at modeling some of the non-linearity in the data, right? And some of the cross interactions between different variables, not just non-linearity but cross interaction between these variables, because you remember that under the generalized linear models we assume that most of the variables which we are taking in our model are independent of each other, right? But that sort of independence or that sort of linearity in functional form or in relationship with the dependent or target variable is somehow not as strictly enforced under the machine learning AI models as it used to be, right? So that is the second part, theory free way of doing modeling or data driven way of doing modeling, which is not making any binding assumption on underlying data generating process or underlying empirical distribution, as well as not confining the relationship to follow certain assumptions, the estimation approach to follow certain assumptions, and also some of the financial theory like markets are perfect, markets are complete, markets are in equilibrium, there's no maybe you know the markets are fair, the markets are liquid. So if you have to price an illiquid asset, what about that, right? Like cryptos, right? We don't have that much history. If you have to price something like carbon trading instruments like green bonds, how about that, right? So there are variety of things which has led to the genesis and disruption by AI/ML models. And as much as all of us are, regulator is no less overwhelmed, right? Because they never had a framework to judge or to evaluate these models in the first place, and what to enforce. So they have put together certain guidelines which are as on date not very specific, but somehow I have deduced maybe through multiple papers that broadly what they are saying. So for maybe the audience in this call, you could follow through what specifically many of these papers, what is the binding theme which goes across these papers, right? In order to say something about specifics, how to build these models and how to instill confidence into these models while seeking regulatory approval for their application and use in real life use cases, right? So the first is that I have bucketed it two way, right? The first is model agnostic risk, right? Eventually we are talking about model risk, because when you submit a particular model to the regulator, they are going to see whether the uncertainties and the risk in whether in data or in estimation approach, choose an estimation approach which you have taken, is properly addressed or not, right? By how the way you have built that particular model, right? So the first thing is model agnostic, irrespective of the algorithm or the choice of the modeling technique, right? These points are definitely must have and to be done, right? Especially more so for maybe uh, the machine learning AI/ML models, because they are built on big data. They're built on big data. They are built on such a data which do data augmentation, means combine the traditional or modern data, traditional and modern data together. By traditional I mean the numerical data, by modern data I mean the tweets or maybe the uh, signals coming from geosatellites, images coming from geosatellites, or maybe some of the other devices, IoT data, right? Maybe generally your social networking data, all of that. Suppose if you just try to combine those with your numerical data, right, then that augmented data would become a bit of very complex data, right? So in such complex data set, definitely there are certain requirements which are agnostic of the model or the technique or the method or the approach you are going to use within the AIML, right, umbrella, right? So the first is DQ checks, data quality checks, that whatever data you are going to use for to build the model should properly handle the missing values, the nulls or the nans, should be able to handle any duplicate or redundant values, should be able to handle any spurious values which doesn't have any significant contribution to explanation of the relationship, right? Should be able to handle outliers or extreme values, right? So in your model document you have to prove what kind of testing, what kind of methods you have applied to for the data preparation, right? And these kind of data quality checks, are must to have, specifically for the complex data set or the augmented data set, which machine learning models generally work with. The big data as well as the augmented data which machine learning models generally work with. The second part is veracity check. Now, if you remember, if you talk about big data, there are four V's, right? The speed at which the big data coming, which we call the velocity, the you know the variety, the various different forms of data, right? Not only limiting ourselves to the numerical data, but also we have tweets, social networking data, we have climate and sustainability risk data, we have images, we have videos, we have signals, we have IoT data, right? All these kind of data assimilated together, right? So that is the variety. So the first is the sheer speed at which data is coming, the real time data or the ticker by ticker data or high frequency data. Velocity, the second is variety, the third is volume. The data is going into terabytes and maybe petabytes, and it is no more limited to few gigabytes. So that's why you require big data platform. The fourth one is very important from regulatory perspective, that is veracity. Now what does that mean, right? People generally confuses this veracity with variety, which is not the case, right? Veracity means that the new age data, the modern data, right, which you are using to perform, to have an edge, right, to perform better data mining and to capture more signals into your model, to build more patterns, evaluate more patterns into your model, to build more relationship into your model, right? That kind of data has a veracity. Veracity means it is not trustable data, it has a huge degree of noise. Like, people, suppose a stock goes up or down, right? There's a stock market data which tells you maybe some drivers of why the stock is going up and down, that is the numerical data. But if I want to build a sentiment indicator, pulling out the what is happening on the social media handles, where many analysts and experts and market pundits and market observers are you know p- giving their prophecy about where the stock will go, right? They are giving guidance about the next quarterly results of the firm, right? So the that kind of data which tells us maybe the market is sentimentally bearish, bullish, or neutral on any given point in time is very important, right? Because the market is not only driven by rationality, but sometimes, many a times, by these thriving emotions, what we call the you know irrational exuberance, right? So that, if you mix up these, augment these two kind of data set, numerical versus the modern data set, which is a bit of Twitter and textual data set, right? uh, you will be very surprised that there's a lot of noise, and people are expressing their opinions. Bulls are fighting with bears, right? There's this different sides to the market where people are making arguments, and and sometimes it's difficult to make sure that this particular data at any point in time, if it is saying the market is bullish or the market is bearish or the market is sluggish or maybe neutral, right? Or maybe a- uh, you know agnostic, then maybe it is very difficult for that to verify. So the regulatory focus is very much on that. Regulator as on date thinks that the volume of uh, you know the data has been managed by the banks, by they have created data lakes and some kind of a big data platforms, right? The velocity has been managed, they have increased the processing speed, right? Added more GPU power or TPU power to the computational speeds and produce some real time analytics. Variety, now they are not only in their data lake or in their big data platforms, they are not only uh, you know ingesting the numerical data, they are trying to use other forms of data as well, which were not previously used: images, videos, voice, messages, Twitter data, social networking data broadly, climate and sustainability data, which is geosatellite data anyway, right? So the only thing which the major thing which would be the focus of regulator for the adoption of AML is the veracity, right? Whether the data you are using, right, uh, is it giving a spurious kind of indicator or signal, or is it giving something, some kind of indicator which is significant for the relationship you are trying to build as part of your model. So that's the point, where regulators are across the board stressing and focusing, right? The data distributional analysis, as I told you that previously it was the case, like, prices are log normally distributed. This distribution look like beta, that distribution look like gamma, that distribution look like poison, right? Now the thing is that, you know ideally the AML models should be built and should have this particular capability to not make hard binding assumption about underlying distributional properties or data generating process, DGP as we call it in modeling, in quants we call it DGP, but it's essentially the underlying distribution, right? So as the data, new flow of data will come in your pipeline, AML pipeline, the AML should be able to adapt to that particular data no matter the distribution change. Whether the distribution, the nature of the distribution will remain same, but sometimes, the same distribution would be a bit left skewed or right skewed, or the distribution also within the same family of distribution, the distribution also change from one to another, right? So so that is the dynamicity of the AML models, the maybe dynamic way of them calibrating to the data, right? But the point is, the stringent requirement is that, having said that, okay, suppose you that is a thumbs up, right? That is a good meritocratic, that is a good merit of AML models. But having done that, would you imagine that you know uh, the the for a regulator or for a reviewer, it is very difficult to understand the data unless they understand the distributional properties of the data. So they want us to examine, or the banks or financial institution to examine, all different variety of underlying distributions which could potentially be, under different scenarios, potentially be manifested, right, for that kind of problem or for that kind of data set. Right? So it's not just about, they are fine that you are not making any assumptions about maybe uh, a stringent form of data distribution, underlying data distribution, but what are the potential different data distributions? Prove us empirically, prove us maybe give us maybe the different movements and the different statistical properties of those particular distribution, and how the data, how the variables would look like if they would be distributed this way or that way, right? How the model would change, how the model would change, right, between two distributions. If you are saying that these could be the potentially few distributions which could be possible for this particular problem, right? Because underlying data generating process under a crisis scenario could pan become a fat tail, under a normal scenario would behave like very Gaussian, right? So on and so forth, right? But tell me how your model will change, right? Because your model is dynamic, right? So that is another focus area. Then on the model performance evaluation, now there's a very stringent focus, because many of these machine learning models, AIML models, are very overfitting. They are very greedy models. They would like to learn as much as they can. They would like to gobble up. They would like to learn as much as they could possibly from the data. So what the regulators' expectation is that we should perform a rigorous out of sample, right? Means that if you have used certain data as your training sample or development sample or estimation sample, use a different data set, unseen data set, for testing the model, out of sample testing. Out of time testing, you have taken an observation period, historical observation period, to build that particular model covering one economic cycle, right? Say from 2005 till 2000 maybe 18, right? One whole economic cycle turned. I have taken this as an observation period. This is my in time. I have built the model by collating or collecting data within this observation period, because this observation period represent one turning of the economic cycle. Now, out of time testing, right, that maybe take a snapshot which is outside of this particular interval, right, this particular window, right? So perform that kind of testing as well. The next part is that any which way these models, since they inherently are good at, right, capturing the non-linearities or the multi-collinearities, or in the data, the multiple interactions between different variables, right, their co-integration or cross effects, that is the complexity, which some of the complex AIML models like neural networks or deep learning algorithms could do, right? But how you would make sure that these models can be explained to auditors, to regulators, to model validators, to model approval forums, to all these stakeholders, right? To model users, right? Because one thing is mathematically building that complexity within the model, and then another thing is, you know, nobody is able to, because those decision makers are unable to make their decision, right? Because every time, they look at the output or results, they cannot trace it back to the input, right? That this was my input, right? And this is something happening within the model, right? And this is my output. Can you explain why output change due to changing inputs? So model interpretability, model explainability, model intuitiveness is another area where we have this as a research topic as well, which we call the explainable AI, right? Explainable AI, right? So that explainable AI is also one of the focus, that while submitting the model document or any model to the regulator, you need to have a a plethora of details on how you have interpreted that model, what kind of uh, tests you have performed, uh, how you would be explaining that model, like coefficients of that model, how you would be explaining to someone, uh, or the parameters of that model, how you would be explaining to someone. And the intuitiveness, whether somebody, a subject matter expert, intuitively understand the model, how the model functions, what are the mechanics, without knowing the mathematics. So that's the another focus area. So these laundry list of maybe things uh, are irrespective of the models. You would do random forest, you would do support vector machine, you would do maybe deep neural network, right? You would do maybe any k-means clustering, irrespective of the choice of the modeling technique, modeling method, or AIML algorithm, right? These would be required. Then there are some model specific risk factors which are very peculiar to, you know one model to another, right, as well as one problem to another, right? So there you have to first of all justify why you have chosen, suppose, a neural network, right, for a particular problem, say derivative pricing and valuation. There could be many plausible justification for that my derivative pricing and valuation problem was so much high dimensional that I need an algorithm which was capable of handling these high number of variables, high number of features, right? So that would be one possible explanation, but you have to explain what is the choice of method and how it is linked up to the problem at hand or the application at hand. uh, if you generally see that there are, some non-linear relationship in regression, you have chosen a support vector machine, you need to justify, okay, because support vector machine has this inherent capability of capturing non-linearity. So we are moving away from linear regression or logistic regression and adopting this support vector machine for this classification problem, right? So one is the choice of AIML algorithm, because this is very problem, this is a married topic or conjoined topic between what is the problem or application at hand, and what is the AIML, what AIML technique, specific technique will bring to the table? And have you tested alternative AIML algorithms as well, right? So it's not just about saying that, okay, support vector machine or neural network could be the best for this particular application use case, but you should ideally have tested 2 3 other alternatives as well to prove that, okay, this is indeed the best method or best technique for this that kind of a problem, right? The other aspect is the choice of target performance matrix, how you measure the variable of interest. The target is the variable of interest, like probability of default or loss given default or exposure at default or price, maybe stock price, equity price, forex price, fx price, maybe fx rate, sorry, interest rate, whatever is the dependent, how you are measuring the performance of the dependent, right? What does that mean is that obviously in a supervised learning algorithm, we would have historical data from which the model will learn the relationship, the model will learn the patterns and the signals, and it will then convert it into, transform it into some kind of a mathematical form through some estimation approach or through some algorithmic choices, right? And then maybe it will give the final results. Now the final results will predict the price, predict the probability of default of a firm, predict the recovery or non-recovery, or rather non-recovery, loss given default of a firm, predict the exposure at default of a firm, predict the loss of the firm, predict the PNL, forecast the PNL of the firm, right? Simple, predict maybe the value of the firm, right? The value of the certain instruments of the firm, right? Now the predicted value versus the actual value, when you try to see how far your model is away from the actual ground truth, right? What kind of error, how, what kind of metrics you have adopted to capture the error of the model, to capture the deviance of the model from the actual ground truth, right? So that is another area which could be different for different models, because error is a function of the modeling approach applied, right? Suppose if I use a complex modeling approach, a non-linear approach where there's a cross term or variable interactions or some kind of a polynomial function or some complex mathematical algorithmic technique or method, if I employ that, my errors are not going to be linear. My errors are not going to be linear. My predictions versus the ground truth, right, need to be captured through a non-linear function. What that non-linear function would be, right? So what is uh, the what is the matrix you have designed to capture the uh, performance of the target which your model has predicted, right? And how you would justify that the kind of deviation the model is making with certain high degree of confidence interval, right? You could say that model will most of the time will be accurate, right? So these are the performance evaluation metrics which where you would measure the uh, you know uh, AIML algorithmic performance based on certain maybe criteria, right? Then how you have splitted the train and test data set. Now people, uh, when we start our course on AIML, the first few session generally goes into digging it so deep that maybe for people to make them understand that AI ML models are inherently very greedy or overfitting models. If you leave it to them, if you leave it to them, they will gobble up the entire data. They will gobble up the entire data, and they not only they will gobble up the data, they will gobble up all the noise in the data, even some data points, right? But ideally a model should only be constrained to understand the relationship, key patterns, signals, while not you know learning anything from the noise in the data, or anything which is like mugging up the data points. Like if there are certain data points which are coming from the crisis period, and in order to predict the model well during the crisis period, my AIML model has this tendency of maybe you know mugging up that data. But no, but data will change every then and now. So so AIML models specifically require that splitting the data into two parts. One is the trained data or estimation sample or development sample on which the model will learn, or the model will be developed, or the model will be estimated. The rest is the test sample on the model will be tested, validated, evaluated, right? So what kind of split you have done the data? Because some models, some algorithms would require more testing, some algorithms would require more data for training, right? So it depends upon algorithm to algorithm that you are splitting 70/30, you are splitting 60/40, you are splitting 80/20, you are splitting 90/10, right? It depends upon algorithm to algorithm. In neural network you would say that, and obviously the overall data is constrained, right? The kind of data which is required, meaningfully data, if you apply all the filters, do all the data cleansing, data massaging, treat all the missing values or outliers and all of that, remove the data redundancy and all of that, the data which is left would not be still be very, you know maybe enough for you to train a model fully, right? So sometimes, we are any which way constrained by data, given that maybe these AIML model requires more data, incrementally much more data than the typical statistical and mathematical and numerical methods, right? So the point is this, that what is your trained test data split? So in some cases, after understanding the AIML algorithm mechanics, you will know that some cases would require more training data, right? And you have to make a compromise that, okay, test data is enough, I would make a 15 or 20 10% reserved and data and keep it aside, right? I would not let model to see this, because the model will eventually be tested on this, right? But to what extent, how, what is your logic behind that, how you have maybe judged the data requirements for both the training phase and the test phase, right? The choice of the trained data, now trained data in itself need to be sampled well, it need not to have some kind of a bias, right? How you have selected the trained data from the population, so that's another thing. I have already talked through the missing values and the outliers, but that was in generic sense, uh, based on the algorithm, based on the problem statement. Some algorithms are very good at handling the missing values and outliers all by themselves, some are not that very good. So there is a certain sense of data pre-processing which you would do under exploratory data analysis, which would go to creating a data set irrespective of the model. Now if you have a specific algorithm, now you understand that this particular algorithm can handle missing values and outliers, so I can live with some, right? I can live with some. Or the other algorithm is very sensitive to, its output is very sensitive to missing values and outliers, so I need to even treat, the generic missing value treatment and outliers even more, right, in some cases. So that is just maybe how you are going maybe and aligning your algorithmic or specific requirements, and maybe trying to do more than what is already been done in the general steps, right? Then the next problem is very common, what we call is like in credit risk, if you have heard of low default problem or low default portfolio, right? We have for the label of interest, or for the class of interest, or for the maybe variable of interest like default, right? The number of defaults in some portfolio, like if you have a sovereign probability of default model or sovereign rating model where you are assigning rating to countries, right? The number of default would be very far few and rare, right? So last time it was in 2010 when these pigs countries like Portugal, Italy, Greece, Spain, they defaulted, and they were also, their default was later averted by the intervention from European Union, right? So and before that maybe or after that there was Turkey, at some point in time there was Hong Kong, you know then there was a Congo, right? But in hundred of years, maybe decade goes by, there are few instances of default, right? Obviously, maybe the countries, the consequences are huge. Many a times the country has been safeguarded by World Bank, IMF, right? You see the case of Pakistan or maybe some of the other distressed countries, right? They have been given loan by IMF or maybe other backers, right? So the point is this, that the default observations are very few. How to learn, you know, to predict default based on the independent features or variables we have, how to learn to predict defaults, right? So how you have handled the labels. So there are certain techniques, right? When there's a minority class and a majority class, and the majority class is so superimposing that minority class is so maybe you know maybe below the counts that we could not learn the relationship, right? That what could possibly potentially lead to default. So in those cases there are certain techniques like smart or some other techniques, like maybe where we do oversampling of the minority class in order to create that class imbalance, in order to address that class imbalance. So what kind of technique you have used there, how you have treated the skewed distribution with maybe left skewed, right skewed, as well as fat tail distributions where the tails are fatter than, or the kurtosis tell you the tails are fatter than maybe the normal distribution, right? So how you handle that kind of thing. So all these aspects are very important, because as I'm again going back to the same thing, in classical numerical methods, it's that we work under a very very strict stringent framework, right? Here some of the boundaries of that particular framework are blurred. We are using modern day data. We are trying to also capture the non-linearities or interactions or polynomial or quadratic relationship, right? We are maybe sort of not constraining ourselves to a low dimensional or a medium dimensional problem. We are moving and covering, trying to cover huge feature space with a lot of variables as much as we can. So there are a lot of, we are not sticking by any distribution that okay, my data is strictly coming from Gaussian or normal family of distributions, whether it be log normal or other distributions, right? Or chi-square or whatever, right? The point is this, I'm not assuming that, right? I let the data would tell me its own story. If it were to change, like during a crisis period, if it would not remain a normal Gaussian distributed random variable, then so be it, right? So when you are changing a lot of things, the regulator is asking you to empirically you know prove, substantiate, you know test, evaluate those particular aspects, and create a transparent submission to the regulator, that okay, as well as to the model validators and auditors and model approval forum, right? That okay, these are the aspects and these are the methods used, and these are the uncertainties owing to the complexity of the how the problem is complex and how we have handled it through an intricate or sophisticated method, right? So that is the thing here. So now coming to how to translate that into a validation strategy, that's the moot point out here, right? Maybe we gathered to galvanize ourselves, maybe some thought provoking idea around that, right? So the idea there is that these are some specific things which would guide a model, AI model, AI or ML researcher or a modeler or quant guy, to how to go about it, right? What kind of things to go about it, what kind of things would be the main focus points. So first thing is, right, model inputs, right? Like model data, whether it is features or variables, whatever, right? How you have sampled the model data to avoid the bias, right? You should not, you know you should do some kind of a sampling technique, right? Like stratified sampling or maybe bootstrap sampling or some kind of a sampling technique, so that your data would not be biased, right? In some way you don't do every time, and you not only do once, you do maybe multiple simulations of drawing that and plotting them distribution and confirming that okay, my sampling technique doesn't create a bias or create a significant bias, right? Okay, right. So some kind of testing of that particular thing, right, and evidence of that particular thing, and how while sampling sometimes you assign different weights to different observations, right? Why you assign different weights to different observations, I told you that sometimes uh, due to the focus that we want to estimate the loss, right, and the loss is generally seen under the crisis. Those years which are characterized as crisis years, you would be the data which would be coming, the data points which would be coming from those years, you would be assigning more weight, and you would be underweighing the normal period and the boom period or the benign period or the upturn period, and you know overweighing the downturn period, say for a loss forecasting problem, for stress loss, right? So some kind of whatever just weight allocation or reweighing you have done in your data set, you need to be very transparently justify that, rationalize that. Data relabeling, it goes back to the same point that when there's a class imbalance in under the classification, one is the minority class, one is the majority class, and there's a class imbalance, how to you know reasonably balance these classes, right? So because we would mostly be interested in uh, knowing the minority, predicting the minority class, whether it's a case of fraud, whether it's a case of cyber crime, whether it's a case of default, whether it's a case of non-recovery or LGD, right? You would observe most of the time that you are talking about these things, but these things are not as many, especially in a uh, portfolio which is where you are dealing with very good counterparties, and those are long term counterparties. These are not everyday a counterparty with default. Every maybe quarter a counterparty would default, or every year rather a counterparty would default. Maybe there would be 5 years or 10 years which go by without seeing any default, right? Or not every counterparty would not pay back. If even if they would default, they would not just the recovery would not be that bad, right? Because we have taken collateral, we have taken other guarantees, we have taken some hedging against the counterparty. So maybe the recovery or data, like there would be very few instances where the recovery was very worst off, right? So how to learn what are those instances which could create more losses? So similarly, there would be very few prices where somebody would make a windfall gain or a windfall loss, right? Obviously there would be fewer price points. So such kind of a you know uh, data is a bit maybe imbalance, right? So how to balance that particular data? What kind of feature transformation, the next point is what kind of feature transformation you have applied now. Isn't it that we said that we want to capture non-linearity, we want to capture interactions, we want to capture polynomial behavior, we want to capture quadratic relationship, right? But that would require you to transform your variables as well, and then standardize and normalize them so that they would come all on the same scale, right? So what kind of transformation you have applied, what kind of techniques you have followed to select your variable set, right? Which which would you would be including in your model. So variable selection or feature selection or feature engineering, right? Whether you have gone about maybe so generally you will start with a high dimensional problem with a lot of features, like maybe hundreds of them, but eventually you would be boiling down to say 50, right? 50 independent variables or predictors in my model, right? How you have gone about reducing that list from 400 or 300 to 50, right? Maybe that is the feature selection, right? And some techniques within maybe machine learning do it automatically, right? So in those cases, if I am dealing with such a problem like in regression, we have methods called lasso or ridge or elastic net which do it automatically, right? Which drop down all those features which under a multivariate setting would contribute very less to explaining the dependent variable or the target variable, right? So maybe so sometimes I use specific machine learning AIML technique to address that particular problem, but sometimes I need to do that feature engineering a bit manually, right? adding few features at a time and then fitting the model and then seeing its accuracy, then adding few other features next time and seeing it accuracy every doing multiple simulation and trying to find what is the best features, which are the relatively best features or contributors to the explanation of the dependent behavior, right? Feature augmentation. Now, I tell you that it's not about just using the numerical data, it's also about using the modern day data. And the modern day data include that I want to build in my price forecasting problems, I want to build a sentiment indicator. I want to, in my probability of default problem or credit risk credit evaluation model or rating model, I want to build a lifestyle score, maybe for retail. I for corporates or for maybe institutions, I want to build a climate and sustainability risk, right? So a lot of image data, maybe signal data, maybe Twitter data, right? All these kind of modern data, unconventional data would come handy, right? To further do nuance modeling. But how you have augmented, how you have converted eventually, there are certain algorithms like convolutional neural network which are very good at processing voice recordings, processing speech, processing maybe speech data, voice data, processing maybe the video data, image data, right? So first of all, you have to indeed apply a machine learning algorithm to take that data and to transform that data into some meaningful numerical form which the computer could understand. Like if it is a textual data, you might end up applying a large language model first, right? And then maybe converting the output, transforming those particular raw values of the various textual values or raw values into some kind of numerical format, and then giving it to your neural network, right? So that is the way how it goes. So it would be within the data transformation, you would be applying a specific machine learning technique, right? Okay, so that is data augmentation. Maybe what is your data augmentation strategy, what kind of different data set you would be using, how you would be combining them, how would you be making sure that any of those are not spurious or giving any spurious signals and they really are important for the modeling problem at hand, all of that. The next thing is noise handling and removal. Now, one thing about financial data set which most of you know, right, but I would like to reiterate and stress here that financial data is very noisy. The more high frequency data you deal with, it is more noisy. It is more noisy. The more high dimensional data you deal with, it is more noisy, right? So as you go higher in dimension or higher in frequency or higher in volume or higher in variety, right, the data will have a veracity problem. It will become you know uh, by default very noisy. How you handle the noise? So there are certain ways, certain techniques where we denoise the data, right? So what kind of those kind of techniques you have employed? Then obviously based on the different features which you have selected in your model and the target, the dependent variable, what is maybe have you checked the distribution of these across your training data, your test data, your validation sample? They should be similarly distributed because eventually you are going to perform the model evaluation on test data or validation data, validation sample or test sample, right? For that, the features, the same transformation need to be applied on that data set as well. But then you need to examine, okay, my features and the target is similarly distributed. The next thing is feature drift. So sometimes the feature in itself, right, show a kind of trending line. The feature is in itself changing, the show a kind of trending line. How you have handled that feature drift? Feature drift also means that maybe some of the key measures, how we measure the financial performance of a particular firm, like leverage, liquidity, or maybe earning ratios, or maybe cash flows based ratios, they might you know under a multivariate setting, they might show a drift, whether you have handled that particular drift in your model or not. So these are some of the uh, specifics around what a AIML researcher or modeler would do during the data pre-processing steps. Then obviously they need to specify the conceptual soundness of the mathematical form of the model, right? If you have choose a particular model like neural network, what kind of number of layers you have included in that particular neural network, what kind of function you have used to convert the neurons, output from one layer to the input to another layer, right? What kind of functional signal processing function you have used, whether it's a sigmoid function or it is a hyperbolic 10H function or whatever, right? That is, I'm not going into technicality, but the point is this: what is the functional form or the mathematical form of the model? If it is a neural network, what is the design of neural network, how deep it is, 10 layers, 20 layers, 30 layers, how many neurons are there in each of these very layer, how many interconnections are there between two layers, right? So the conceptual soundness, what kind of design you have chosen, right, for of the model. Because neural network, the same kind of same technique could take different architecture, different design. So I could build it really deep, I could build it somewhat narrow, I could build it maybe with a dense network, right? Maybe there are different ways of building it, there are different architectural and design of the same neural network. Say suppose recurrent neural network or artificial neural network, the same could be built through different ways, right? Different architectures. So what is the justification behind that? Choice of the design, choice of the architecture, choice of the estimation approach, choice of the functional form, mathematical form of the model. Now then it comes to the estimation approach, specific about estimation, whether the estimation approach is good at detecting patterns and denoising the data, avoiding the noise, right? It is immune to the noise. It should be good at detecting only the patterns, capturing only the patterns, not overfitting the data but optimally fit the data. Whether the next point is related, whether the it create a optimal fit to the data at hand. uh, then there are certain goodness of fit measures where we check that, okay, what kind of fitment it is creating on the training data set, right? Then there are certain measures where we check that, okay, whatever it has learned from the fitment it has, or the estimation it has, or the relationship it learned from the training or estimation or development sample, whether it is able to journalize that using an unseen data, right, which is test data or validation data. So model generalizability, how a model regularize or journalize its learning on a new sample which it hasn't seen, because the portfolio could change. Tomorrow you might have new trades in your portfolio, you might be doing new derivative trades, you might be dealing with new counterparties, you might be giving new products, new facilities to the same counterparties. So the data is bound to dynamically change, and especially in the evolving world, portfolio is not dynamic, right? Okay, right? Whether it's your hedging requirement or your maybe portfolio allocation decision, that should also be based on some kind of a model which capture that portfolio dynamicity, right? So that requires the model not only to learn and give a accuracy on the data from which it has learned, or the training data, estimation data, or development data, but rather journalize its understanding quite well, right? Producing the same kind of accuracy or precision on an unseen data, like test sample or validation sample or blah blah blah. Now the next point is that many of these models, AIML models, we are talking about AIML models, right? Many of these models have something called hyperparameters. Hyperparameters means, I told you that the same random forest, the same neural network could be built using different architecture, right? Now random forest, you could have taken gone built up a deep random forest or a narrow random forest. You have uh, 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 built up a very splitted random forest. We have taken multiple splitted trees within that particular random forest. So what are the hyperparameters? Hyperparameters are those parameters which tell you what is the architecture of that particular model. So that requires a lot of simulation and a lot of hit and trial and experimentation, right? Where we understand that, okay, for us to build a neural network, these many layers would be optimal, and these many neurons sitting in each layer would be optimal, and these many density of connection between two layers would be optimal. For a random forest, these much depth would be optimal, otherwise it would start overfitting, overlearning, learning the noise, blah blah blah, right? uh, uh, and this much number of decision tree and this splitting criteria would be optimal. So some of these would require some kind of experimentation, which would then support your choice of that particular algorithm, or not only algorithm or method or maybe AIML technique, but also the specific design and architecture, right, for that AIML technique, which is very optimal for the problem at hand, right? So hyperparameter tuning, so hyperparameter need to be fine tuned and optimized for high performance, so that it would not lead to underfit, it would not lead to overfit, it would give you a optimal fit. Then the topic I already talked about, that how certain techniques within AIML have handled high dimensionality of the data. Suppose if you were to, for the same sovereign risk use case, if I were to go to macroeconomist in IMF and World Bank, or maybe in Asian Development Bank, and I have to collate all those maybe variables like GDP, GVA, unemployment rate, industrial production, CPI inflation, WPI inflation, crude oil prices, right? Maybe global supply chain risk, right? Maybe the risk of any war or disruption, right? Oil prices, right? Collate all those maybe factors. The list would go into run into hundreds, right? Now the it would naturally be a high dimensional problem, because you are assessing, a country's default default risk, which would include its fiscal deficit, fiscal surplus, trade deficit, trade surplus, imports, exports, industrial production, inflation situation, interest rate situation, a lot of regulatory framework, legal risk, right? Government risk, right? Transparency International, what it says about the corruption, ease of doing business, climate and sustainability risk factors. A lot of the list could go unbounded. It would naturally become a high dimensional problem. Now, should we keep it high dimensional? Obviously, right? Yes, but how to reduce that particular dimensionality? Because high dimensional problem are inherently make the model complex, and once the model will grow complex, it will try to capture the noise rather than patterns, rather than relationship, rather than signals. So how to handle that particular dimensionality problem? And then last but not the least, the calibration appropriateness. The calibration appropriateness means that how model parameters, how the model results and outcomes, the predictions or the forecast will align with the historical data, right? How you would make it, you know stick to the length of the data, how default varies across a particular economic cycle, how you would calibrate the model, right? So the calibration of the model should be, AIML model should be to the most recent data, because you want to capture the most recent history. Because as you go historically, you could use the huge historical window for your model training, but the calibration should be based on the actual recent history, because some of the market microstructure changes, some of the way the market functions changes, some of the regulations have changed, some of the innovation has come up in the market, right, which has brought new kind of derivatives, new kind of products, new kind of trading way, right? So all due to all these multitude of factors, if we calibrate the model to a, you know uh, using a data which was a bit yesteryears, we won't be able to capture the current market situation, the current market environment, the current regulatory environment, the current policy environment, right? The current maybe overarching industry, state of the industry or state of the sector for which you are building the model, so on and so forth. So all these things maybe need to be checked, and some of these things would then form part of your validation strategy. But with only validation strategy, it won't work, right? Because AIML models, there's another thriving requirements which is enforced on AIML models, that which I am breaking down into two, that how you would make AIML models more explainable, which is called explainable AI, right? A topic called explainable AI, interpretable, comprehensible, intuitive, how you would bring about that. So there's a separate this is a separate topic, and you could maybe see, maybe we have had a session on this particular topic where we have covered the explainable AI by using something called a game theory, that there's a different way and technique how a game theory could be applied, and something called a specific method called Shapley analysis, the explanation, how to explain the coefficients or parameters of the model. So that's maybe you could refer to that session, which was a deep dive session on that particular topic. But the idea here is that the model should not be viewed as a completely, or the model results or outcomes or predictions or forecasts should not be viewed as completely coming from a dreaded black box. It should be reasonably, if not completely, white box or gray box. People should be able to gauge, trace, have some analytical traceability of the results, right? uh, and the second requirement here is that model inference time, that the time it requires for somebody to understand the results, right, should be within the acceptable range based on the intended application. Like, suppose if you are a front office pricing team or valuation team, I say that you would need, suppose the time taken by you is 5 hours, based on, I have designed a neural network to do some exotic derivative pricing, right? Some Bermudan options or American option, or maybe a digital barrier or some kind of, right? Now you would say that I'm I cannot spend more than a half an hour, right, in understanding the results to take the decision, right? Or maybe less than 1 hour, right? Okay. But now the model is built so it has some, lack of explainability, that the users are required to devote 5 hours at least to themselves get confident to take the decision. Now that is not maybe what maybe is desirable, and hence, that time, inference time, should be cut down within some acceptable range or permissible range for the application use case at hand. Then next is a lot of model fairness and ethical issues, right? That maybe some of these AIML models, the regulator has niggling doubts that it will create some kind of a discriminatory behavior, right? It will maybe give some over privileges to some cross section of or some strata of the population, and it will take away benefits from some others, uh, because these are more intelligent models. Like, uh, I'm putting a thought out there, that when you become human, how your neuron system works, right? You understand things uh, on a very abstract level, that okay, somebody is male by gender, somebody is female, and somebody is transgender, or maybe you understand somebody's sexual orientation is this, somebody is this, they are straight, somebody is non-straight, right? Somebody ethnicity is this and that, somebody socio-economic class level is this and that. You understood it, right? But who asked you to judge people just because of that? You have the pinnacle of intelligence to apply your own judgment, and to apply maybe your own biases, or to apply your own experiences, and project your decision in that. Now machine learning models or AI models are also inherently the same, right? The more they learn about data, they're also going to start judging, right? So how to control that particular prejudice, how to control for that particular bias, how to control for that particular maybe impartiality, how to come control for that particular discriminatory behavior if seen in the model. So the model need to be tested for all these things, that it is not specifically, suppose a lending, right? It is not only giving preferential you know rates or preferential loan amounts to only one strata or cross section of society, while leaving another strata or cross section of society. ignoring other strata or cross section of society, because the model is quantitatively built. It would see that, okay, if I lend to that minority, not that discriminatory that sensitive class, right, uh, I would hold more risk. It doesn't mean that you should then discriminate. You are holding more risk, then you should, you know anyway you are required to diversify your portfolio, right? And as long as it's not about somebody is from LGBTQ, but it's about that if that person holds the merit, he's educated, he has the right kind of income or serviceability, would you still discriminate, right? So that's the problem, that we have to build such models without, so that the ultimately they are not trying to discriminate based on some bias, prejudice, or some kind of a judgmental thing in an unfair way, because it could tomorrow lead to a lot of litigation, especially in developed economies. People could use the litigation to uh, impose millions of fine and compensation on you if you discriminate against them, right? If you discriminate against handicaps, if you discriminate against LGBTQER, whatever, if you discriminate against transgenders or whatever, right? So nationality, or maybe somebody is immigrant, somebody is non-immigrant, right? This is another major focus where we are trying to build a broader set of tests for the model to check its design, that it's fair, it's fair in its decision, because there would be very low touch point that a final decision maker would do, and that would be at a portfolio level. But at a position to position level or counterparty to counterparty level, how the model is giving decisions, right? uh, in order to instill confidence in that, we have to prove the um, you know that very crucial aspect, that the model is behaving very fair, right? It is not giving unfair hand, it is not dealing with unfair hand with any particular cross section or start of the maybe broader population. So these are all maybe what I have to cover, but on the last slide I have collated all those uh, very good or recent papers, though they are not as specific, right? If you go through them, but you could go through them, that these are the papers, the latest one from European Union or Bank of England, or even in India from Niti Aayog, right? European Banking Authority, Fed, right? UK, again UK, FCA, Financial Conduct Authority. So all these Monetary Authority of Singapore or Germany, BaFin, right? Or maybe CS2, right? Data, Australian, maybe. So each one of them are now trying to put all those wrappers of regulations to ensure that these kind of models would be you know taken on their merit. And that merit criteria is very broad based, right? It covers the ethical, it covers the trust, it covers the explainability, interpretability, comprehensibility, it covers the maybe understandability of the model, right? It covers maybe also the fact that maybe that AIML model should be a white box or a gray box, not be a black box to anyone, right? So it covers all those aspects, but it is as of now very, very uh, how to say, not pinpointing to specific test or specific things which bank has to do, right? So those kind of things maybe could only be deduced, which I have deduced here, right? But you know you could, if you are a good researcher, you could do more on this and maybe try to see how to further give some specific food of thought for your AML adoption while working in this very versatile regulatory environment, and maybe distrust among stakeholders in for AML adoption, how you could pave the way for the next level of growth in the AML adoption by creating more specific tests, more specific evaluation metrics, more specific points where you would create transparency around the model. Yeah, so that's maybe I'll pause here and maybe let the rest of the session to follow through maybe some kind of a Q&A and interactions so that I could hear more.
Yes, absolutely. First of all, once again, thanks for that engrossing session. It was pretty informative. So to the audience also, I hope you all had I mean, you were able to understand those aspects quite well. Of course, these are uh, sessions which we try to cover a lot of stuff in, like, again, in a short period of time to give you a fair bit of idea, right? So, so as I've told in the beginning itself, so we would be having a question and answer session. So we would be happy to take up questions actually, right? So please feel free to type in your questions. I can already see a couple of questions already have come, right? But before we go to the Q&A session, maybe just to give a little bit of breather to Sanjay, and also to since like a lot of you generally ask how to get into this kind of field. So maybe very briefly we would be talking about, like, again, what we have been doing, and how we can actually help you in, like, charting out in a career in the interesting field, right? Because the thing is, like, again, this is definitely a field which is of huge interest to everyone. And very quickly I'll summarize the resources that actually you can utilize from our side. So I'm not going much into the introductions of, most of you actually by now know, we are the oldest quant body in India, and we focus specifically on quantitative finance and financial engineering and risk management and AI/ML application in finance and all these areas. Educating people in this kind of field, right? So, for those who are interested, because this is like a field which is of interest to many people, because this is where the world is moving into, right? Both from the quant analytics side of areas in finance, as well as like the applications of data science, machine learning in finance, right? So anybody interested in making a career in this field, whatever area you are already working in, or, like, again, if you are a fresher, you're a student, or you're a working professional who want to enter into this kind of fields, we have courses for everyone. And good thing is, all the courses that we do, these are all courses which you can do along with your job or along with any other degree that you are pursuing, right? So these are pretty comprehensive, intense programs, but it's spread over, like, again, good 6 to 9 months, right? So that, like, you have enough time to build a deep background, and you are ready to make a career in this kind of field in quant or risk management or algo trading or derivative valuation pricing, joining or as a machine learning or data science experts in finance. So very briefly, we have as I was mentioning, this courses. So the first course that I'd like to introduce here is like a certificate program in artificial intelligence for finance, which is a course which teaches all aspects of data science and its application in finance, and it teaches all aspects of machine learning and its application in finance. And also it has elective modules which allows you to specialize in specific areas. There are 4 electives on offer: AI for risk management, AI for trading, AI for derivative valuation, and generative AI for finance. Anybody doing this course, you can select any one elective to specialize. However, this course is totally modular as well. So if somebody does not want to go through the entire course, they can selectively learn a part of the course as well. Say, for example, if somebody wants to learn only the data science and big data and all that application in finance, they can do this data science for finance module, which then becomes a 3 months module. Or they can only learn the machine learning aspects in finance, the core areas of supervised learning, unsupervised learning, big data, NLPs and neural networks and its application in finance. They can do this machine learning for finance module specifically, then it becomes a 4 months course. Or if somebody already has a very good background in data science and machine learning and they want to only do the specialization modules, they can separately do the specialization modules as well, right? So where you can specifically choose to then directly join the specialization modules, and again you can go deeper into these areas, right? So you can go into AI for trading, you can choose to do a module on AI for risk management, or AI for derivative valuation, or generative AI in finance. Depending on your interest, you can directly go into these modules. Yes. However, if somebody has an interest in like making a career into more deeper areas of quant or financial engineering or algorithmic trading, we have specifically designed courses tailored to prepare you for those roles as well. There's a course on certificate program in financial engineering. There's a course called certificate program in quantitative finance and risk management. These are both courses which teaches the quant domain in deep. So if you are interested in making a career as a quant, or in the risk management departments or risk management teams, these are courses you can do. Somebody interested in algorithmic trading, again another very interesting specific area a lot of people are interested in nowadays. So this is, you have a very comprehensive course called postgraduate program in algorithmic trading, which you can use to enter into this kind of field, right? As I mentioned, all these courses are weekend live and interactive lecture based courses conducted on the weekends, so you can build your skill sets, join the field, and make a wonderful career. We do have a placement support system as well, right? So again, quickly, I mean, these are just we have the last 15 years of our existence, we have been fortunate to have a lot of professionals and students who have done our courses. I mean, you can go to the page, this testimonial page of our website, just to understand how people use our courses to make their careers in this kind of field, and you can be using this courses as well, right? So yeah, very briefly, I mean, we do have a strong support system on placements. If somebody wants to make a career in this field after doing these courses, and it starts at the onset when we start talking with you, even before you join our courses. So even before you join, our mentors will actually guide you and selecting basis on your profile and basis on your interest, what kind of course or which course you should be selecting. So they will deep dive, understand your background, and suggest you. And once you are part of the course, all the courses are taught by senior leaders from the industry who are definitely experts in the modeling aspects in all these areas, right? So they are all basically faculties are all leaders working in international banks, big four consulting firms, or hedge funds, trading desk, and all part of like the actual modeling and practical trading industry, right? So they would be your mentors during the course, and then after the course, there's a dedicated placement support team who would be coordinating with you in the entire process, starting from resume building, interview preparation, and then again helping you by connecting with the right kind of teams and getting you the interview calls. I mean, being the oldest quant body in India, there's a strong network of industry association we have built over the years, and we definitely would be leveraging that to help you with your placements. Right. Okay. I mean, these are the profiles that you can be targeting by doing this kind of courses in this kind of companies, maybe in hedge funds, investment banks, international banks, stock exchanges, your consulting firms, IT companies. So, I mean, all the companies that work, and of course, I mean, there are new set of organizations like all the fintech organizations and all. So you can target all of these organizations in the specific teams related to the quant, risk management, trading, machine learning, data science. So anybody interested in like making a career, they can look at all these courses, right? Yeah, I mean, a very small sample set of job opportunities or like the kind of profiles. Again, we practically have worked with almost all companies in this field over the last 15 years or more, right? This is a very small list of example or sample organizations just for you to have an idea. But again, this is just like a small list. And yes, in our endeavor to promote the quant field in India, I mean, we work with educational institutes as well to promote this field. And these are again just like a small sample of educational bodies. We also work with, like I mean, the NITI, which is IIM Mumbai now, IIT Madras, BITS Pilani, IIT Roorkee, IIT Bombay, to name a few. I mean, so we do try our bit to promote this field among students also, because a lot of students don't understand the importance of this field when they are studying, right? So I mean, there are a lot of people who have a solid background to make a career in this field, but when they are students, they are not aware of this. So we try to do our bit in making them aware. In fact, for students, we do have scholarship schemes as well to help them actually do this kind of courses and make a career, right? All right. So, in case anybody wants to have any more deeper discussion in terms of like their career or any of the courses, these are our contact coordinates. IIQF.org is our website. This is one of the contact numbers you can contact. You can email to us at info@iiqf.org. Right. All right. I think let's go to the questions now. So we have quite a few. So quickly going through them one by one. So Sanjay, I'll be collating the questions for you.
Sure, Nitish. Yeah, go ahead.
All right. So the first question that we'll be taking up is from Subham Parihar, and he has mentioned, sir, how much important it is for a data scientist to have a knowledge of cloud, and can you also tell what is the current trend of automation, particularly in relation to data science? How are data scientists and analysts using automation in their work?
Okay. Yeah. Okay.
Yeah,
So
that's a
I think
question.
yeah, Shubham, you need to just disentangle different roles in the industry, right? The one you mention here is more of a data engineer role, right? Which is more of a IT role which serves to the data scientist, right? So a data scientist would understand the cloud deployment, because anyway, when you are building the models, many of your models, the final deployment would be on cloud. So but the main engineering job or the IT kind of job role family which helps uh, a data scientist in order to strategically deploy on a cloud platform is our data engineers. And basically, not only that, but they host the data on the cloud, they deploy the models on the cloud, they sometimes ingest different data which I talked through, the both the conventional and the unconventional data in your data lake or big data platform like Scala, Spark, Hadoop, or all of these. So your question was maybe how it could be you know catered to a data scientist so that he would understand not just about data science or statistics, mathematics, probability, data science methodologies, but also about maybe how the upstream infrastructure works and how the downstream infrastructure works. We have specific sessions which are designed to provide a deep dive into all these upstream data infrastructure and downstream maybe model deployment, right, which let front to back kind of thing, right. And as I'm saying that if you are going into a pure data scientist role, you would not be required to do that yourself, but you need to have a good degree of awareness that what are the technicalities and what are different platforms like big data platforms or different clouds, and what are the considerations while choosing one kind of architecture versus other, right. Or that kind of design and architectural principles should be taught and should be very clear and should make part of the ammunition of a data scientist. Yeah.
Absolutely. So I hope that answers your question. If you have a follow-up question, please feel free to type in, and we would be taking up. But now going to the next question. It's like a pretty elaborate big question actually from Paranjay, and he has asked for good afternoon, sir. First of all, thank you so much for the great session. Wonderful, Sanjay. Thank you for letting us know. It's great to know that you liked the session. He says, I have a few questions. I'm currently working on a statistical arbitrage strategy, trying to predict the Z scores of the co-integrated pairs, which I derived from k-means clustering and statistical tests. from stacking slash voting of different AI and ML models like XGBoost, Random Forest, LSTM, PPO, multiple regression. Number one, while making the model, I came across copulars in the dynamic adjustment part of model via distributions. So I'm confused how to use copulars also with changing models when the distribution changes. And number two, how can I use simulations like Monte Carlo, etc., to get evaluation metrics percentages like 95% time the drawdown of the strategy will be X, etc. Okay, very big question actually. Like again, so do you want me to repeat the question or?
No. I got it in letter in spirits, and I'm quite delighted that we have such nuanced audience asking such elaborate questions. I appreciate that. So first of all, thank you. Maybe so I'll go in a structured way. So the your first part is that I think what you are trying to do, statistical arbitrage, trading strategy, is you are trying to employ or maybe research on the pair trading, right? So, and your question there was that whatever you are doing, maybe different techniques or methods or algorithms, right? Are they correct, or is there a specific way of going about it? Now, pair trading, generally could be done through a sequential modeling, right? Maybe that's where maybe most of the research paper says that you could build a recurrent neural network, right? And do some of the correlation and covariance matrices between the correlated or covariing pairs. You could then maybe go and draw some insights, right? Which pairs you know sort of evolve together, right? Which particular two different asset classes or two different securities like gold or cryptos, right? Or maybe between two specific securities within the asset class, right? They have a co-integration, or they have a correlation, or they have a covariance, right? You could build that co-integration model using some of the uh, typically time series models. There are specific co-integration models there as well, right? Plus you could use the recurrent neural network, by which I mean that you could use the LSTM and GRU, long short term memory and gated recurrent unit, right? So, and the other part is where you said that okay, I'm doing some clustering, k-means clustering, obviously. So that is part of data processing, where you would first of all interrogate, right, that in my portfolio which pairs hold that strong sense of maybe correlation or strong sense of co-movement, right? Obviously that is any which way required, because there are few things which you are doing as a data scientist to gain insights before applying a modeling technique, right? But eventually the modeling technique, to my knowledge, to my limited knowledge, is like using an RNN there if you want to use maybe the some kind of a good machine learning algorithm, right? The other part is that you come across copulas, right? And copulas means that obviously distribution properties and underlying data generating process is changing, right, across different intervals of time. It is not homoscedastic, rather it is heteroscedastic. The distribution is changing, right? Now the copula modeling in itself is a specific subject which is called tail modeling. It is specifically looking into the tail behavior, right? So there are two ways of doing it, right? Or that is, I think, the approach which industry follows. They build a separate models for tails. They built a separate models for modeling the center of the distribution, right? And then they integrate the two, they combine the two, right? Because tails would not hold forever, right? Like for example, economic loss or stress loss topic, you would like to see more of retail behavior. Why would you be interested in the body, right? You would be seeing the highest losses, right? So there the copula modeling will do your thing, right? But in general market, if you would be pricing, valuing, or predicting any variable of interest, that would be within the normal maybe behavior which will not violate unless it is a extreme crisis or a extreme scenario or extreme market volatility. So uh, just disentangle these two, right? Have separate models for these two, because these might take different functional form, and you better understand this, uh, maybe because you are also practitioner, that in your main body model you would not capture the cross terms as rigorously. Might be you capture somewhat, you would want capture the cross term as rigorously as you would like to capture in your tails, because many of these driving factors or influencers or predictors will interact together to vary, right? So that's why maybe I think that you should build these two separate models. And the last one I think was on something on confidence intervals, right? If I'm not
Yes.
wrong.
So last part was how can I use simulations like Monte Carlo simulation, etc., to get evaluation metrics, percentages like 95% time the drawdown of the strategy will be X, etc.
Mhm. Okay, so that again comes from plotting your errors and plotting your loss function, right? If most of these confidence interval based tests, right, they draw upon, right, the how the errors are distributed, right, the standard error of the model, right? So you need to perform some standard error test, right? But for that you need to have a understanding of what is your loss function, what is your error function, right? If that functional form is clear, right, then you could apply these particular tests, many of these tests, and you could devise your own test as well. But if that is not clear to you in the first place, and the error is rather than being random, the error is showing us some kind of pattern, it means that it could be further reduced. It is not irreducible error, it could be further reduced, right? So you need to do some specific analysis on the error terms or the loss function of the model, right, in order to bring in some idea of that within these bounds, within this confidence interval, I'm I'm saying that my model will be pretty accurate, right? With this confidence I'm saying my model will be pretty accurate. So that kind of, there are specific tests for that. But in order to do that, you need to do something with your errors or something with your loss function, and in order to gain insights into what your loss or error function is, because many of those statistical tests would make some assumptions about the errors or the loss, right?
Absolutely. Right. So I hope that answers your question. But anyway, if you have a follow-up, please feel free to ask. We will be happy to take it up. All right. Next question is from Niharika, and she has asked, could you please give an example of LLM models broadly used in BFSI?
Okay. Yeah. So there, LLM is part of what we call the NLP, natural language processing. So when it comes to text mining or text transcription or text processing, we use mostly LLM models, and specifically like the areas where you are doing some compliance activity with the BCBS or Basel or EBA or European Banking Authority or these super regulators. You would require, suppose I'm taking a use case, you would require LLM model to understand the compliance reading through multiple, like Fed Reserve a policy document, or maybe EBA policy document, or BCBS policy document. The plethora of policy documents out there. Then there are some independent research firms which on also publish the policy, their documents on a specific topic about regulation and regulatory compliance. Your idea is that for me, right, as a researcher, what I need to do to be fully compliant, right? So you need to understand it from multiple facets, and you might end up developing a NLP or large language models with a corpus of words or word vector which could understand those particular regulatory texts and could give you that, okay, these are your controls you need to implement. I'm taking a example, just trying to create run of the mill example. These are your controls. These are specific governance topics, right? You need to focus. These are some of the modeling, thing where you have to do something with data, or you have to do something in order to choose an estimation approach. So how to develop that? So you could develop a NLP algorithm. The only thing is, let me maybe, the prompt, right? That, okay, you would train your data on all these different kind of lingos, terminologies, parlance, which you find in these regulatory documents, to make it learn, right, and interpret what the regulatory text really means. But the thing is that before applying that model to the real use case, you have to do a lot of prompt engineering. And sometimes, there's a problem called uh, hallucination, that maybe your large language models or some of the NLP model hallucinate, right? So you require some kind of a training time where you give them a particular word, that, okay, extract me the controls which the Prudential Regulatory Authority of India or Financial Conduct Authority of maybe UK has said, right, to for me to implement on the models, right? And then maybe you need to test it that it is giving to you the right controls, and it required training and retraining, because sometimes it will hallucinate, it will not understand. Somebody would say control, somebody would say check, somebody would say those verification steps, right? Now these three words, you need to make the model train that. In some documents you would find a word verification or control or maybe checks or maybe validation tests, right? Or data validation or maybe those kind of thing. So it's not a specific name to the algorithm, but the name is given by the application, right? But it's essentially training the model on a word vec, or a huge corpus of words, right, to make them sense out of a specific context, give them contextual intelligence. In which context regulator is saying this, right? Once they become contextually intelligent, and you will, you know test and retest them and train and retrain them as required, then they would could be deployed.
Absolutely.
So it
All
goes
right.
to AML compliance, it goes to your Basel compliance, regulatory compliance, it goes to even auditory compliance. So many of these big four companies, how they perform their audits and what are their audit policies, how they are enforcing that. So they are also building some kind of NLP or large language models to do the prima facie or preliminary audit without involving the actual auditor, without involving the actual auditor, to give a sense maybe of maybe what are where the gaps, where are the inconsistency in the financial statements, right? It could be used in forensic audit, it could be used in many cases. So wherever there's a huge textual thing where somebody who is trying to do that particular task need to go through a lot of documentation, right, a lot of variety of maybe different kind of documentation, you could build that those kind of NLP algorithms.
Yeah, absolutely. All right. So now, before going into the next question, actually, like again, we are already 20 minutes past our allocated time, but I mean, we do have few questions, so maybe we'll take 3 to 4 questions, and that would actually anyway cover the questions that are there. Some of them are a little repeat as well, what we have covered. But maybe in the next 10 to 15 minutes, we will take up the remaining 3, 4 questions. Right. So, okay. So the next question is from Karthik, and Karthik mentions a great session. Thanks, Karthik. One question: do we have any tools for implementing these checks, or do we develop these in-house?
So look, it depends, right? Some of these things are reusable once developed, right? It depends which particular firm you are working with and at what maturity level in AIML adoption they are, right? Like some of the firms where I worked with, some of these tests when I joined were in the phase of development, right? And some of the firms which I currently work with, there I had have to even go and do research that, okay, what kind of things should be implemented given their data and given their modeling problems or application use cases. So it depends, maybe some of the fintech companies would already have it, but it then again require you to meaningfully adapt that to your problem, right? So if your data is more noisier, or if your data has more missing values or data quality issues, right, then the what the test specification says, then you have to maybe quite adopt it to your kind of thing, right? But in the overarching ML pipeline, once they are built, some of the standard tests would be there forever, like they would cut across different models, specifically those one which are model agnostic, and then maybe you have to do a bit of tweak or adapt, or maybe to your problem statement, or to your problem set or data set or whatever.
Absolutely. All right. So going to the next question from Adil. Adil has his question is non-linearity in data these days are rampant in financial data or
Mhm.
high dimensional oblique frequency data. Which are the methods to use in AIML and how it will be different compared to econometrics method?
Okay. Yeah. So
Right.
many of the econometrics oblique statistical methods, they somehow enforce linearity. It doesn't mean that they completely ignore non-linearity, but they transform non-linear variables or features to make them linear, right? Because they have some binding assumptions. Now, under the guise of AIML, right? This is not the case, because we are not building theory. The philosophically, we are not building theory centric model or theory driven model or assumption driven model. We are building a data driven model. So ideally, some part it could be a mix and match, because still we are working in a very tightly regulated space. We might control for some non-linearity by transforming it wherever we think that that non-linearity would not play a big role, right, after evaluating in big contribution in our estimation or in our forecasting or in our prediction. But for some of other thing where the non-linearity is indeed playing a big role, we would use the kind of the major classification side, we would use the support vector uh, classification, SVC. On the regression side, we would use support vector regression, SVR. On maybe if you are dealing with a high dimensional problem, first of all you would also do some principal component analysis or PCA, or maybe singular value decomposition, that would also bring down the high dimensional problem, and also to an extent handle the non-linearity and interaction between similar variables, covariates,
Right.
right? And then maybe neural network also are is very immune to very good at capturing the non-linearity. So essentially just one point, it's the functional form. If the functional form is so, like in neural network we say that it is a universal approximator, right? So the functional form is not linear, it's not strictly linear, right? So that kind of functional form would always try to capture the non-linearity, because that is of interest and that would make the results more accurate and precise, right? So if the right kind of algorithm and right kind of method and technique would be used, like SVR or SVC or neural networks, or some of these, maybe even random forest to an extent, then you could build such non-linearity into your model.
Absolutely. I hope that answers your question. Going to the next question is from Chetan, and Chetan has mentioned, rather his question is, how important is to have feature store and model registry in model development and validation strategy focus?
Mm, so can maybe feature store? What do you mean by feature store? I think this is a technical term reserved for something, right?
Yeah. Okay. Okay, so I'll
I
repeat the question and then maybe I'll ask Chetan to maybe elaborate a little bit more. So his question is, how important is to have feature store and model registry in model development and validation strategy focus? So question, any follow-up question
Yeah,
you
yeah.
would
So
like to ask?
as far as maybe I understood it, I not that I fully understood it, but I could say that for model traceability, that if you were to prove any of your steps to the regulator or the auditor or whosoever the stakeholder is who is inspecting or reviewing your model, right? You need to have these feature store and model registry, right?
So,
So that you could show
so
them.
he has added, actually, sorry to interrupt. He has added feature store it is currently used in MLOps.
Okay, okay, then so I got then maybe somewhat right. So you need to have this. Why? Because your code should be reproducible, your code should be traceable, right? It's not about you are submitting a set of documents, model document to the regulator, you are submitting this code as well, so they are going to replicate on their side as well, right? So for those kind of things, definitely whatever you said, feature store and model registry is required, because how they would replicate a step that you have experimented with different estimation techniques, right? Somehow how, and whatever you are saying in your model doc, or you have used different data sampling techniques, somehow you have used different missing value treatments or transformations on the data, but you eventually boil down to one, or which was less immune to maybe any kind of uncertainty, right? So for all these things, some of the replicability and reproducibility of the code is required. For that, hence it makes sense to have that, because unless you have feature store and the model registry, you won't be able to do that. Yeah.
Wonderful. So I hope that answers your question majorly. So let's go to the next question. But again, we'll take only two more questions actually, because we have already uh, extended our time by half an hour. But anyway, like we always want the session to be interactive, and like again, if we have good questions, we'll always be happy to extend time and answer those. Thanks, Sanjay, for taking your time out and answering these questions. But anyway, when still, since we are already half an hour almost past our allocated time, so maybe we'll quickly wrap up by taking two more questions. In any case, most of the questions has been taken up, so sincerely, some of them are repetitive actually. So next question is from Subham, and he said that, sir, I have seen an issue always with principal component analysis.
Mhm.
When I use PCA to reduce the dimensionality of the data, and when I use that data for creating, let's suppose, k-means clustering, then I have always faced issue to interpret the results. How to interpret the results after using principal component analysis as it transform the data?
Okay, that's a good, very good question indeed. So when you are performing the PCA is submerging many of the multi-collinear variables into one principal component. Suppose you have taken different debt ratios, debt to capital, debt to total assets, debt to equity, right? Debt to maybe cash flows, whatever, right? Essentially, and you on your correlation plot, you find them to be significantly correlated. Now you could not maybe have all of them in your model because they would be overlapping in their explanation. You decided to do a PCA, right, to have one principal component which you would call, say, the leverage risk of the firm. Now while doing the PCA itself, at that step only, you could perform an additional step which could decompose and tell you that for that one, I'm calling each PC a index, right? Now understand, because it's a assimilation of multiple factors. I'm saying decompose this index into its constituents, means features. What feature contribute to this index, what feature carry what weight, right? That to equity carry what weight, that to asset carry what weight, right? And then I'll keep that in my memory, means I'll store somewhere as a reference data. When you do k-means clustering or whatever, right, the next steps will only be on index or principal component. Sometimes you have to trace back and decompose the final results, right? That these are my centroid for this PC or that PC, based on these multiple PC, and then convert that back into, right, the features by using that mapping. And that's what we do, because PCA is any which way, as you said, is completely in a black box way, combined multiple factors, and you have no traceability what its constituents are and to what an extent each constituent was playing a role in that PC, right?
Yeah, absolutely. Okay. So maybe we'll take the final question for the day from Vedant. And he has asked if there is insufficient data, are algorithm-driven models preferable instead of data-driven?
So sometimes, Vedant, even that is also very intelligent, incisive question. Now, insufficiency of data is not that unseen in finance. We have quite a lot of data set where we are insufficient, right? So we would rather synthesize some data. Synthesizing doesn't mean creating synthetic data, doesn't mean that plucking it out of cloud. Creating data, synthetic data means first you understand the distributional properties of the data and draw from randomly from that distribution, right? Without any bias, right? So creating some, using some generating some synthetic data, creating some synthetic data to further augment. So your data augmentation strategy would be, now you have a problem, insufficiency or inadequacy of data, right? Sparse data or scanty data, you would rather do synthetic data and corroborate or maybe augment your data, so that that would be enough for your modeling problem. To what extent you would do, whether that would be acceptable or not, for because if your model really require huge amount of data and you end up using 60-70% of synthetic data, and the application at hand is very critical for regulatory purposes like capital calculation or RW, whether regulator will give approval or not, that's a separate question. That's a separate question. So based on the application, like if you are using it for internal application like pricing, risk appetite, loss, stress loss, or economic loss, then it's fine. But if you are using it for regulatory application, you need to take regulator blessings and their support, that okay, going to this. And sometimes they are also practical, they understand this. If you prove this, that you have gone to every data vendor source, Morningstar, Thomson Reuters, maybe S&P, Moody, Fitch, this, that, right? You could not get data. And somehow you want to build something scientific around that. They could support you in some cases, but it then depends upon that whole argument, right? That maybe what is the how legit way you have created that synthetic data and whether that was indeed required, right? Or if regulator would challenge you that you could have used some other data set from some other vendor, why you haven't used that. But if you have a legit reason, I don't think that maybe they are unreasonable based on my interactions. Yeah, they're hawkish, but they are not unreasonable, right?
Yeah, wonderful. Absolutely. So I hope that answers your question, Vedant. Okay. Subham Parihar, he wants to check if you can, if he can have your LinkedIn link, Sanjay. He wants to connect. So can we send it to him?
Yeah, definitely. Why not? Yeah.
All right, Subham. So we would maybe send the link by email or WhatsApp to you separately, and definitely you can connect with Sanjay. All right. So with that, let's conclude the session for the day. I mean, we have already extended time, but it was wonderful interacting with all of you. I mean, there were interesting questions, and as I said, I mean, we want the sessions to be interactive, and we prefer to extend time if needed and answering the question rather than actually not answering the question. So thanks for everybody's patience, and I mean, but it was a very, I mean, great interaction. Thanks everybody for the wonderful questions as well. And thanks once again, Sanjay, for your wonderful session and also your, uh, I mean, special time taken to answer all these questions very patiently. Yeah. Thanks, Subhas, for your
Thanks all.
wonderful comment. Thanks, Paranjay. Yeah, Paranjay, we'll share the LinkedIn link with you as well. All right. So with that, we conclude the session for the day. I mean, as you all know, we keep on having this kind of interesting sessions on various topics of importance in areas of quantitative finance, financial engineering, risk management, machine learning, data science applications in finance, algorithmic trading, and other relevant areas, right? So do keep track of our website, our social media pages for the next upcoming webinars. We generally have webinars every month, So keep track of our pages, and of course we will also intimate you over like again emails and other modes whenever we have the next webinars. So see you all in the next webinars. I mean, thank you once again everyone for taking your time and joining. Thanks once again Sanjay, especially for taking your time and for the wonderful session. Thank you.
Okay, thanks all. Thanks, Nitish.
Thank you.